Okay, now here is an example. The road mileage between city M and several selected cities is shown in the table. If we consider this as a function that pairs each city with a distance, is the function a one-to-one function? So this is another way of asking if an inverse function exists for this relation. Right, so first of all, notice that it is a function because if if I know it's city A, I know the distance to city M is 1,400 miles. B, I know the distance is 774. C, and so on. And there are no repeated, like city A is not paired with any other distance to the city M. So it is a function, but that's not the question. The question is it a one-to-one function? So we could assume it's a function because it says with a distance, the road mileage between several cities is shown. If we consider this as a function, right, so assuming it is a function, then is it also a one-to-one function that we can invert, right? Is it possible to find a function that will invert this function? Right, so we want to know if going back the other way, if it's monogamous. Like if I know it's 1,400 miles, can I assume we're talking about city A? If it's 774 miles, can I assume we're talking about city B? Or is there more than one city that's exactly 774 miles from M that I would have to choose between? And you'll notice that there are no repeated Y values or output values. In other words, there's no two cities that are that have the same distance from M, so it is one-to-one. So we would say yes, it's one-to-one. And now I want to write it out in function notation. So we've seen this sort of f of x notation already. And this is a discrete function, meaning it is a set of ordered pairs that I can list. A and 1,400. B relates to 774. C relates to 1,074, and so on. Now, some new notation is inverse function notation. So it almost looks like an exponent, or it really does look like the exponent -1, but it is not. This notation indicates that we are inverting the function f. And the reason that notation is used is because if you have x, the inverse to that, the multiplicative inverse to that is 1 over x, and another way to write 1 over x is x to the -1. So we're illustrating the inverse relationship between two functions by using this notation, but it does not mean that it is an operation of raising f to a power of -1. Now, the inverse is that 1,400 maps back to city A, 774 miles maps back to city B, 1,074 miles maps back to city C, and so on. So what you'll notice here is that functions that are inverses of one another have opposite x to y values. Or in other words, let me come up to some other questions that are in here. That the domain of f is equal to the range, because it's going to swap x values with y values. The domain of f is equal to the range of the inverse function, and the range of f is equal to the domain of the inverse function. So x and y swap places. Another way of saying this is that it reflects across y equals x. So I'll show that in a bit, what I mean by that. Number 1 up here says for a function to have an inverse, it must be one-to-one, right? We can't invert it unless they are monogamous in both directions. And now let's look at number 3. It says if a function f has an inverse and f of -3 equals 6, so that indicates the ordered pair on f. It indicates that the ordered pair negative 3 comma 6. If that is one of the function values for f, then for the inverse function, we would say it would have to contain the point 6 comma negative 3.